So just in case you guys forgot. This is our horizontal, and this is our vertical. Okay. So now let's talk about the slope of each individual case. Okay. Now, believe it or not, the slope is actually 0. In other words, it's actually this example right here. Because you're literally going not up or down, just a flat line, just trekking along like a train. So you're not going up or down, so your slope is literally just 0. You're not going anywhere up or down when it comes to it. You're a constant line across. Okay. However, when it comes to vertical lines, this slope is undefined. Okay. Now, if you're wondering, why is it undefined? Well, let's see what happens. So let's just quickly do an example when you have a vertical line. So let's suppose we have these points here. And we also, and again, we just want to find the slope of these 2 points. So let's do that, right? So this is going to be x1, y1, x2, y2. So this is B slope is 18 minus 10 over 3 minus 3. Okay. So these ends up being 8, and this ends up being 0. There lies the problem. Unlike over here, where you have 0 over a number, whenever you have a number over 0, this doesn't make sense in math, meaning this is a no-go. Right? You can never have this happening. So whenever we have this situation happening, we always say it's undefined. Okay? So that's why a vertical line always has an undefined slope, because if we actually would plot these 2 points, well, we have 3 and 10, and we have 3 and 18, that's a vertical line. So vertical lines always have a slope that is undefined, meaning it doesn't exist. Horizontal lines, on the other way, just like this example, have a slope of 0. So it does exist, we're just not going anywhere when it comes to it. It literally is just a flat line. We're not going up or down, we're just trucking along, for the fun. Okay. So that's on top of now of what we did earlier, right? So if you guys want a little other portion, so and has no x-intercept, right? That's what we learned earlier. And this and has no y-intercept, right? So now we have 2 things that are very special when it comes to vertical and horizontal lines. So now if I ask you what are the 2 things that are special about a, let's say, for example, horizontal line, you can say 1, slope is 0, and the second one has no x-intercepts. Or I can say the same thing for vertical, right? For the 2 important things a vertical line has. Or again, I can say what's a type of line that has undefined slope? A vertical line, right? And there's no other line in the world. Just all vertical lines are undefined. So, right? So just those are concept questions, right? That can happen, on the homework and also on the exam. So it's not really any math. It's just understanding, which situation goes for which particular one. Okay. So any questions to finish up this page here? All good? So that finishes that page. So we're almost done with this section, believe it or not. We just have a couple more examples and we're pretty much done. Okay. Go on to the next page. So I'm going to skip this kind of right now because we're actually going to be talking about this situation in the next section. So I'm going to skip this one and go mostly for the first part. It says graphing a line with a point and a slope. Okay, when it comes to it. So this part is easier if I deal with it in 2.5 itself. Okay, so we're going to figure out how do we graph a line if we're just given a slope and a point when it comes to it. Okay, so let's do some examples of finding the slope and then graphing the line itself. Okay, so let's suppose first example is we give it to you like this. So I give you a slope, m is equal to 2/5, and I give you a point, 1, 1. And I ask you, graph the line. Okay, so we're graphing lines. We're just going to make some graphs. Okay. So first off, what we're going to do is just plot the point 1, 1, right? So 1, 1 is right here. Okay. All right, wasn't too bad when it comes to it. But remember, we want to graph this line, so we need at least 2 points. So what we're going to do, we're going to use our rise over run. Right? So what this is saying is I'm going to go up 2 units, so it's positive, so it's going to be going this way. I'm going to go up 2 units, and I'm going to go across 5 units. Okay. So let's see how this is going to work. So I'm going to go up 2 units from this point. So 1, 2. Right, 1, 2. And then I'm going to go across 5 units. So I'm just going to count 1, 2, 3, 4, 5. And that's going to be our new point right there. So then we just make the line crossing them, and we are done. So notice I don't put a point here, right? That just helps me get to the next point we're looking for. So I started here, and that was the next point I needed by using our slope. So if you're wondering, right, this is up 2 units and across 5 units. Questions there? Everybody comfortable with that example? Okay. Let's try another one. So let's suppose I give you something like this now. And same thing, I asked you find the slope and graph the line. Well, that's not fair, right? Here I gave you the slope, so that was done, and we just had to graph it. But this one, we have to do both, right? We also find the slope and also have to graph the line. Well, now we know there's 2 different ways we could do this. We can use a t-chart, or we can find the x and y-intercepts and plot those. So since we learned it in this section to find the x and y-intercepts, why don't we do that for extra practice, right? So we make a t-chart, and we want to find the x and y-intercepts. So to find the x-intercept, I'm going to plug in 0 in for y and see what I get out. And the opposite to find the y-intercept, right? I'm going to plug in 0 in for x and see what I'll get for the y value. So let's do the easiest of the two. Let's plug in 0 in for x and see what we get out. So 2 times 0 plus 4. So that's just going to give you 4. So you got 1 point, right? 0, 4. Okay. Next, we're just going to do the opposite. We're going to plug in 0 in for y and then solve for x. So 0 in for y. So subtract 4. divide by 2. So x equals -2. So that is our x and y-intercepts. So now let's graph them and see what we get. Right, so first point is -2, 0. So -2, 0. Next point is 0 up 4. 1, 2, 3, 4. Right, just plot in the points. And now we just make a line right through them. So we graphed it. Okay. Well, we graphed it, but we still haven't found the slope, right? So we still got to find slope. But now it's up to you how you want to find the slope. You can either use rise over run, or you can use the equation, because now we have 2 points, right? -2, 0 and 0, 4. So you can use the equation, or again, you can just use rise over run. Okay. So again, just for fun, I'll use rise over run to do this. So again, if you don't like it, you could just use the equation, right? It really is up to you how you want to do it. So this goes here, this goes there. So I know it's going to be positive because I'm going up. So how many units am I going up? So let's see, it's 1, 2, 3, 4. So 4 total units up. And how many units across? 1, 2. 2 units there. So my slope is how high I go up, so that's 4. And how much I went to the right, which is a 2. Or simplified, just 2. And there you go. Questions here at all? No? Everybody comfortable with that example? So no questions? Okay. Everybody good? Just do a couple more then, so for practice, extra practice. All right. Example 3. So let's suppose we're given that. And again, we want to graph the line and find the slope. Okay. So we could do the exact same thing we did here. Find x-intercept, y-intercept. But again, let's suppose you hate that way. You like the old-fashioned way of just using a cheat chart. And that's why it's literally up to you how you choose, right? All we're here is just to give you guys different options on how you want to graph a line itself, okay? So again, let's suppose you don't like this way and you just like the old-fashioned way, you pick your own values. So I'll pick my own values. So I'll just pick, let's say 2 and let's say 3 for fun, comes to it, okay? So I'll plug in 0. So I plug in 0. That all goes away and I just get a 4. So that wasn't too bad. If you ate fractions, right? Let's also plug in 3. Okay. All right, so 3 is also not that bad because 3 times 2 is 6. And then 6 divided by 3 is 2. And then 2 plus 4 gives you 6. All right, perfect. That wasn't too bad at all either. All right, so we got our 2 points. So let's just graph it. Right, so 0, 4. And then 3, 1, 2, 3, up 6. And there we go. There is our line. Questions at all there so far? No, not too bad. Okay, and the last part is, well, what if I want to find the slope? And you do the same thing. You can go rise over run, or if you want, you can use the equation, right? Since we already have 2 points. So I'll just use the equation. So these are our 2 points we found. This is x1, y1, x2, y2. So my slope is going to be 6 minus 4 over 3 minus 0. So 6 minus 4 is 2, and that is 3. So there is our slope. So that's how fast we're going. We're going 2/3. Any questions there at all? So everybody still comfortable? Okay. So before we finish up, go to the next section, there's an example I do want to cover. And it's this one from your homework. So for your homework, you have to do in section 2.4, you have to do 69 and 71. Okay. So if you want, these are the applications of, slope and stuff like that. So what I want to do is I'm going to do an example of how 69 is going to be. Okay. So all I'm going to do is just change the numbers. Okay. So let's say some dropouts. So let's say in 1970, the number of high school dropouts in the United States was, let's say, 6,000. Okay. By 2020, this number has decreased to, let's say, 5,200. Okay. Find and interpret the average rate of change per year in the number of high school dropouts. Okay, now we haven't really talked about average rate of change, but I'm going to give you guys a little hint. Average rate of change is slope. It's just a fancy word for saying slope. Why? Because physics people think they're so special. That's why. But it is just slope. So, yeah. So when you think physics people talk a lot and do some crazy words, it just means the same thing in algebra. They're just trying to make it all high and mighty. So average rate of change literally just means find the slope. That's all they're saying. Now, if you want, okay, how do you find the slope? We're not given any points. And believe it or not, you actually are given points. So if I go back to the question, So I said in 1970, the number of high school dropouts in the United States was 6,000. There's your first point. So 1970, comma, 6,000 is your first point. Your second point is by 2020. So 2020, comma, the number has decreased to 5,200. That's your second point. So your second point is 220, 5,200. And then it says find and interpret the rate of change. In other words, find and interpret the slope and the number of high school dropouts. Round the answer to your nearest tenth. And that's just rounding when it comes to decimal. So let's do that. Oh, so before we go any further, any questions of what I just said about this example? So what I'm about to do is very, very similar to what you do here. So in other words, these are 2 points there. Okay. And now we're just going to find the slope. So this is x1, y1, x2, y2. So it's going to be 5200 minus 6,000 all over 2020 minus 1970. Okay, and I'm pretty sure I have to pop out a calculator for these. These are pretty big numbers when it comes to it, but still doable, right? Although it is. So I think this is a negative 800 at the top, and this is going to be what, 30, 50? I think that's it. And if you simplify, I think you get 80 over 5. And if you want a decimal, oh, it goes in nicely. Negative 16 is your slope. So very, very similar. You would do for your homework. Now, if you want to know, how do you interpret what the slope means? Okay. So one cool thing, again, all that's saying is in words, what does this number represent? That's all it's really saying, when it comes to it. And that's what the difference between basic math and higher math is just now interpreting what this comes into play. And you see that a lot if you guys are going to take stats. Is like, what does this number actually mean now? What does it actually, do to the problem itself, okay, when it comes to it. So instead of 16, I'm going to go here to make it easier so you guys can see the actual difference, okay? So remember, slope is the y over the x value, right? Now, if we go back to the question, the y values are the students. So y's are students. And the x values are years. Okay. So we know y are students and x's are years. So what this is saying is for every decrease, so minus means going down, right? So for every decrease of 80 students, oh, I can't write. The per means the division symbol. Now per what? 5, what though? Years. So that means there has been a decrease of 80 students per every 5 years when it comes to this model here. And that's always going to be the case when you're interpreting slope. Is decrease or increase depends on the sign. So if this was a positive, that would be an increase. So for every increase of 80 students per every 5 years. So it increased 80 students in 5 years, or in this case, it decreased by 80 students in 5 years. Okay. And again, and all you have to figure out is what is the y value and what is the x value, and always put per right after that. So it's the number, and then what's the y value? Per means a division, and then the number, and then what are the x values? The years in this case. So again, before I go any further, any questions on the interpretation of a slope, or in this case, that. And it is always y first. It is always y first, followed by x. This is the y, followed by the x. In that order, never the other way. If you're wondering why, remember, the top number is always the plus or minus. That's why, because that tells you going up or down.